Hi, I'm Dr. Chad Larson. Thanks for joining me in another episode of Keep It Real. Today we're going to do the second episode of a three-part series on the neurotransmitter dopamine. I talked about in part one that I did a presentation at a medical conference in Las Vegas, and I talked about dopamine. So I thought I'd just give you just kind of the major points that I got to, because dopamine imbalances are actually pretty common and they manifest in a whole bunch of different ways. So last time we talked about basically the evolution of dopamine, and what researchers suggest is that it was actually dopamine which is manifested, it's developed in the mid part of the brain, kind of what we call the reptilian brain, or the really old part of the brain. There's kind of the old cortex and then kind of the neo or new cortex, and that part of the brain where dopamine is made is kind of a very old part of the brain. We call it the midbrain. And what researchers now suggest is that it was those neurons that make dopamine that ended up evolving over a pretty long period of time, kind of stretching into the cortex, the neocortex. And some suggest that it's actually those neurological dopaminergic projections into the front part of the brain that really led to the prefrontal cortex, which is really what separates us from other non-human primates. So it's where a lot of very high function, cognitive function, decision making, all the executive functions that really make us human happen in that prefrontal cortex. And dopamine has a very large part to play, particularly in the evolution of how the prefrontal cortex was developed over a very long period of time. Also, we talked about how our understanding of dopamine has evolved over time. Remember, like over 100 years ago, dopamine was just considered, just another biochemical, pretty insignificant. They didn't really understand what it did, and so it wasn't really regarded as much. But over the period of time from the 1950s to the 60s and 70s, we started to have better technology to evaluate the brain, evaluate things like the receptors of the brain, and that's when they really understood that dopamine is actually a neurotransmitter. There's lots of dopamine receptors in the brain, and we started to really understand the importance of what dopamine does for us at the brain level. And so that kind of leads us to our part two today, which is we're going to talk about kind of what dopamine does in the brain, what it does for us, and then on the flip side, what it does, what are some symptoms that might manifest when things go wrong. So instead of really using the term dopamine deficiency, I'm going to refer to it more as dopamine utilization issues. If dopamine is just not being utilized properly, it might not just be it's not being made enough. There could be problems with the receptors, there can be problems with just other parts of the cofactors and the building blocks that dopamine requires to be made. And in the third episode, we'll talk about some things that really influence the way that dopamine is formed, so we can talk about some therapeutic strategies. And so this time we're just going to talk about some symptoms and also what dopamine does in the brain. So when I first jumped into the world of dopamine, I was looking for what motivates people. I didn't really think of dopamine was going to be the thing that I found, but I was looking for what is happening biochemically in the brain that separates one person who's very motivated, sets goals, accomplishes those goals, and then people who have good intentions, but they're not able to quite follow through and have the motivation to complete those goals. And what I came across very quickly was some work by a researcher out of UConn, the University of Connecticut. And what he did back in the 90s is he created these things called T-mazes. And these T-mazes are it's basically it's a box, and it's about 1 foot wide and about 3 feet long. And it's basically a long corridor where they could run different studies on rats and mice. And so here's what they do, is the mouse is first in a little kind of holding area, and then they open up the door, and the mouse is allowed to go into this 3 foot long corridor. And in this corridor it has some decisions to make. If it looks to the right, there's 2 food pellets. If the mouse looks over to the left, there's 4 food pellets. And so he gets to decide, do I want to have 2 pellets or 4 pellets? And of course, they're hungry at this point, so they're going to go and eat the 4 pellets. And so that's just what basically happens. But then where it gets interesting is when they put a barrier. They put a barrier off to the left where there's 4 pellets. So then they do another experiment where they open up the door and the mouse goes in and it's got a decision to make. Either 2 pellets that it can acquire very easily, or it has to climb over the fence, climb over the barrier, and then it could enjoy the 4 food pellets. And so here's what they did, is they, the rats or the mice that had a normal amount of dopamine saw that barrier and went, no big deal. I could see that that reward is just on the other side of the fence. No problem. I'm going to climb over the fence and enjoy that reward. And that's what they did when they had enough dopamine in the brain. But in the rats where they had dopamine deficiency or dopamine utilization issues, they looked left and right and they went to the right. There's very easy 2 pellets of food, and they looked to the left with that big barrier and they went, man, that looks like a lot of work. I just don't think I'm going to put forth the effort to get those 4 food pellets. So they would just eat the 2 pellets. And so this is where they started to really understand motivation, because when they removed the barrier and they had, half the rats had normal dopamine function and the other half had impaired dopamine function, the ones with impaired dopamine function, if the barrier's not there, it's going to go eat those 4 pellets, meaning it's not a lack of enjoyment of the food pellets, it's that it actually didn't want to put forth the extra effort of climbing over the barrier to get to those pellets. So it was lack of kind of motivation. And so this really leads to a further understanding. This was in the early 90s, and this research model has been replicated over and over again by that researcher and many other researchers, and in different ways, and they kept coming up with the same conclusion, that if there's a normal amount of dopamine, the animal model uses the dopamine, really supports the decision-making process. Do I want to put forth the extra effort to enjoy that benefit? So it's a cost-to-benefit kind of decision-making process. And what we know is that a similar thing happens in humans. So what dopamine really does for the body is it helps to give us a certain amount of motivation, because if we set a goal, and remember kind of evolutionarily, maybe the goal is there is a fruit tree orchard 6 miles away, way up on that hill. Do I want to put forth the effort to go gorge myself on fruit and then bring some back for my family and friends? If the cost to benefit ratio is in their favor, they're going to put forth the effort to go get that fruit, or maybe to go hunt down some wild animal to kill it. That's a lot of effort. It takes a lot of motivation. So they have to have the proper decision-making process in the brain to take the proper steps forward to accomplish that goal. And that's dopamine. Dopamine is what allows us to do that. And then when we accomplish that goal, we get a little reward. We get a little dose of pleasure, and that's dopamine. And so that helps us to do it the next time. And that's really been kind of the base of our success as humans, is having the motivation to accomplish that goal, and then we get that little biochemical treat, that little reward. But it's also involved in the decision-making process. It's involved in memory. So it very much supports that prefrontal cortex, that executive of the brain. But when all this goes wrong, all the opposite stuff happens. And this is what we can sometimes see in patients who have things like ADHD, attention deficit hyperactivity disorder, or an inability to stay focused. Oftentimes dopamine is not being used properly from the midbrain to the prefrontal cortex. There's oftentimes apathy or lack of motivation. They know what they need to do, but they just can't take the proper steps to get that done. Oftentimes people who have dopamine utilization issues get into addiction, because whatever the drug or activity of addiction, some of those things we talked about last time, cause an almost sort of artificial release of dopamine, and that becomes their source of dopamine, whatever that addiction is. Could be alcohol, it could be recreational drugs, it could be gambling. And so they get a little hit of dopamine when they engage in that activity. So that's how they kind of artificially kind of self-treat, is by doing that activity, which causes a release of dopamine, but it leads to addiction. So there's a big downside to that. Also, memory loss and depression are common symptoms of dopamine utilization issues. So there's kind of an upside when dopamine is really working right, and there's some very clear, significant symptoms when dopamine is going wrong. And for the most part, these things could be treated with natural medicine. And that's what we're going to go into next time. Next time, we're going to talk about kind of the pathway of dopamine production. And if there's problems along that pathway, we'll talk about what kind of things we can do to support the pathways neurologically and biochemically to help the body produce dopamine and for dopamine to work properly in the body. So dopamine is a really, really key neurotransmitter. It's involved in movement, it's involved in pleasure and reward, it's involved in kind of the emotional, mental part of our brain, and we know that it's involved in motivation and the whole cost-to-benefit decision-making process. So it's very much what makes us human, which is why I wanted to present this material at this conference. And so next time, we're going to go a little bit more into the biochemistry, and then we're going to break it down and show you where things can go wrong, and then more importantly, what we can do to rebalance it. So I hope you join next time for part 3 in this 3-part series on dopamine. And until then, keep it real.